Yes, are you audible?
Great. Now, second thing, type
Yes,
your
sir, you're
city name in
audible.
the chat. Let me see from where people are joining. Let me know your city name in the chat. Then we'll directly come to our topic, that is campus area network. France, oh my god. See the power of technology. You can join from anywhere around the globe. How it is possible? This is possible just because of network only. Which network? WAN network, wide area network.
And I'm happy to join you from Zambia.
Zambia, great. Glad to see you here. Okay, so people are joining from the globe on the world. It's great. Now, without wasting our time, let's begin. One more thing, guys. Please let me know in the chat that my screen is visible or not. Okay, Pakistan, great. Yes, is my screen visible? No, yes,
Yes.
yes.
Visible.
Great.
Yes, it's
So,
visible.
okay, thank you. Now, guys, please put yourself on mute. If you want to speak something, then definitely you can unmute yourself. But if you are not speaking, please keep yourself on mute so that we can focus on content. Otherwise, it will be complex, difficult for me also to focus on content if I will get noise. Okay. So put yourself on mute. You can use chat. Even you can speak. You can unmute yourself. You are allowed to unmute, and then you can speak. People are still joining. Fine. So our topic for today is campus area network. See, guys, what we are going to learn today in this webinar. We are going to first discuss campus area network. What is campus area network? How to design it, how to configure it, what popular protocols we need to implement in the campus area network, where we are going to use it, the scenario, some example like the college, university, hospitals, corporate campus. After that, we are going to implement all the protocols in the network, and then we'll check that my end devices are able to access the resources or not. There should be redundancy, network should be scalable, right? So whenever new client will come, so we can handle the new client as well. Fine. So campus area network is one type of network. So first question is types of network. How many types of networks are there? Types of network. So guys, technically, or if I will talk about the topology defined, then we have two types of network only. Only two types of network. One is LAN and another one is WAN. Local area network and wide area network. See, now how we divide the network? Guys, we didn't divide network on the basis of users. So we cannot say how many user can be there in LAN or how many user can be there on in WAN. Right? This is incorrect question, because what I told you, we didn't divide network on the basis of users. We divide network on the basis of area, on the basis of area, which is domain. In networking term, we are saying domain. So we divide network on the basis of area, and we have two types of network. One is LAN, another one is WAN. Now what is LAN and what is WAN? So guys, implementing network in a small geographical area is known as LAN, local area network. And implementing network in large geographical area is known as WAN, right? So hope it is clear. Types of network, we divide network on the basis of area. We have two types of network, LAN and WAN. If we are implementing network in a small geographical area, like in a building, on a floor, that is called LAN. Or implementing network between two building, three building, that can be also considered as LAN only. And implementing network in large geographical area is known as WAN. Like, let's say I have some branches in India. One is in Delhi, second branch site 2 is 500 kilometer apart from the main base location in Mumbai. Let's say one branch is in Bangalore, or one branch is US, Canada, Australia, India, like this. So here my network is spread in large geographical area. So this network is known as, guys, WAN, wide area network. Fine. Before talking about the CAN is, by the way, part of LAN only, right? Because there is no any network types in topology defined called CAN, campus area network. We have created this network type CAN, right? And CAN is a part of LAN only. CAN means multiple LAN. CAN means multiple LAN. CAN equals multiple LAN, local area network, right? Hope you know the benefit of network, why we are using network and why network is so important for company. Reason, guys, with the help of network we can exchange, share information easily. We can have centralized resources. Like suppose your organization have some employees, 500 employees are there, or 100 employees are there. Let's say 10 employees are there in your company. All need one printer. All need one printer so that they can print out. Let's say your company is like content writing based company, right? All the employees are writing content and everyone need printer. So how many printer is required? We need 10 printer for 10 employees. But with the help of network, we can have only one printer and we can share that printer to everyone, to all the employees. That is called shared resources. Now my resources is shared to all my employees. So this is the benefit of network. With the help of network, what we can do? We can share the resources. Like your printer, your server. Let's say in your company there are some servers, mail server, FTP server for the file transfer, for saving the file, downloading the file. You have HTTP server, you have some portal, let's say HR portal. So we are going to, these are the services, you can say resources. We can place these resources on server, on any server, all the services. Maybe we have multiple server, 10 number of server, 20 number of server, and whatever services we have like HTTP, HTTPS, FTP, TFTP, mail, printer, right? Whatever resources, services we have, these services should be accessible from all my employees. Now, if my employees is directly connected with this server, then definitely employee can access all the service. So employee who is sitting here in front of server can directly access the resources. As well as if the employees are not sitting here, they are sitting, let's say, at different floor. This server is at ground floor and my employees is at first floor, second floor, third floor, right? Then how those employees will access these resources? Those employees can also access these resources with the help of network. Now what we need? We need to connect all employees together first, and then all employees to this server, right? So guys, if I have multiple computers, like employees computers, and I need to connect them all together, can you tell me the name of centralized device that I can use to connect these all computers together? The centralized device which we are using nowadays to connect multiple computers or multiple networking devices is switch, right? So here I can have one switch. With the help of switch I can connect all the computers. Now this network is what? This network is LAN. What we can say? We can say this is local area network. This is local area network. In the same way, we have similar scenario at second floor also. At second floor also we have similar scenario. We have some employees. I have one switch. And all the employees are connected with switch. Now how first floor and second floor are going to communicate with each other? We need to connect these switches together, right? So I can use one another switch here. I can use one another switch here to connect these two floors together, like this. This network is what? Also LAN, because still network is in a small geographical area inside the building, right? Now but these all employee can communicate with each other if you will connect this switch. If this employee want to access these resources, we can connect this switch to the server also. This network is also known as what? LAN, local area network only. Local area network. Now guys, just suppose we are going to implement network in a college where we have multiple buildings. So in each building you are going to implement what? LAN, like this. You will have employees PCs, laptop, it can be IoT devices. Some devices are wired, some are wireless inside the building, right? And inside each building you have LAN, local area network. If you are going to connect these all buildings together, so that network is known as CAN, campus area network, means multiple LAN. Inside the building here we have what? LAN, local area network. Here what? LAN. Here what? LAN. And connecting multiple LAN together is known as CAN, campus area network. So guys, campus area network is type of LAN only, multiple LAN. And in one building, let's say I have servers. Second building is, let's say, MBA department. MBA students are there. Third building is engineering department. Engineering students are there. Computer lab there, right? Many other labs are there. And those all employees' devices should be connected with each other. Then all devices should be connected with these servers also. So we need to connect all building together. So first of all, let's design one CAN, campus area network. So guys, I have some PC here. These are the PCs. PC1, PC2, PC3. Like this, you can have multiple PCs. How to connect these all devices? Through switch. Which switch? Access layer switch. Access layer switch. What is access layer switch? Guys, there are many types of switches. Access layer, distribution layer. If you don't have idea about the architecture, then let me tell you about the architecture first. Network architecture, Cisco network architecture. So Cisco said, whenever you are going to implement the network, you should follow one architecture. Why you should follow the architecture? If you will follow the architecture, it will be easier for you to manage the network. Whenever problem will comes, it will be easier for you to troubleshoot it. It will be easier to configure it, manage it, troubleshoot it, right? For the redundancy, you will have redundancy. If any device will goes down, then also you will have connectivity. So if I will talk about the best common and most useful architecture model, then guys, that is called three-tier architecture model. Three-tier architecture model. Three-tier architecture model means we have three layers here, right? Core layer, distribution layer, and access layer, right? Access layer you will have light devices. At distribution layer you will have high configuration devices, and at core layer you will have very high configuration devices. Guys, I am getting some noise. Yeah, access, distribution, and core. So access layer switch is responsible to connect n devices together, right? Like here I need to connect multiple pieces, 3 pieces, 10 pieces together. So I will use one access layer switch. Access layer switch is going to connect n devices together. Distribution layer is going to connect multiple access layer switches together. Multiple access layer switches together. Actually, this distribution layer is responsible for distributing the traffic, right? Like, let's say inside the building there are 10 floor. 10 floor. So distribution layer is going to distribute the traffic between all the floors. It will distributing the traffic and it will be collecting the traffic also. And core layer is responsible for internal and external routing. Like if you have one branch in India, one branch in US, so core layer will be connecting both branch together. Distribution layer will be collecting and distributing traffic between multiple access layer switches, and access layer switches responsible to connect n devices. So here these are the n devices, and I have one access layer switch. Through this access layer switch I have connected all n devices together. Like this, guys, let's say this is a network at first floor. In the same way, I have same network at second floor also, same network at third floor also, same network at fourth floor also. At each floor you will have what? Access layer switches, which will be connecting n devices, means the computers of client. Switch 1, switch 2, access layer switch 1, access layer switch 2, access layer switch 3, and access layer switch 4. Right? So now all my n devices are connected with access layer switches. Now we need to connect these all access layer switches together. So I will use distribution layer switch, right? So let's say here I have two distribution layer switch. Distribution layer switch 1 and distribution layer switch 2. Why we have two distribution layer switch? For the redundancy, for backup, for the load balancing, right? So if I have multiple switches at distribution layer, we can have multiple types of scenarios. Everything depends on your configuration, how you are going to configure the devices. If you want to achieve load balancing, you can achieve load balancing. If you want to configure primary and secondary switch, you can configure like this. So you can see all access layer switches are connected with both distribution layer switches. This is my distribution layer switch 1. I can say D switch 1 and D switch 2. D switch 2, distribution layer switch 1, distribution layer switch 2. Now guys, there is redundancy. Let's say If distribution layer switch 1 will goes down, then also first floor and second floor can communicate with each other, because they are connected via switch 2 also. If any link will goes down, no problem, still there is connectivity between each floor. So this is the benefit of using multiple distribution layer switch here, right? Then now all the floors are able to communicate with each other. All the floors are able to communicate with each other. Like this, guys, if I have multiple building, this is one building, right? This is one building. Like this, if I have multiple building, building 1 here, building 2 and building 3, then this is what campus area network. LAN 1, LAN 2 and LAN 3. Multiple LANs is known as campus area network. Now question is how we can connect all building together. So guys, see, the cable which I have used here to connect end devices and access layer switches is Ethernet cable. Ethernet cable. If distance between devices is up to 100 meter, then we can use Ethernet cable to connect devices, networking devices together, because Ethernet cable need low maintenance. Maintenance is very low in Ethernet cable. But if you will use the fiber cable, then fiber cable is high maintenance cable. We have to route the cable very carefully. If your cable will bind, then it will not work. But between the building, let's say distance is more than 100 meter, then I cannot use Ethernet cable. If distance is below 100 meter, we can use Ethernet cable. So to connect these all distribution layer switches together, what we can do, either we can use Ethernet cable or we can use fiber cable, right? And then I can connect these all switches together like this. Right? Now all the building can communicate with each other. All the building can communicate with each other, but still there is issue. What is the issue here? Issue is how you can separate the traffic. Guys, let's talk about the LAN 1. Inside the LAN 1 in building 1, we have multiple departments. There is HR department, there is admin department, right? The servers, some servers are there, right? Some finance peoples are there. So these are different types of traffic. These are different types of traffic. So to differentiate the traffic, different types of traffic, we have a tool called VLAN. VLAN stands for Virtual Local Area Network. Virtual Local Area Network. LAN means implementing network in a small geographical area, and VLAN means dividing one LAN into multiple parts. So with the help of VLAN, what we can do here, we can divide each types of traffic, each department. If we have 4 departments, I can create 4 VLAN, and we can put admin in, let's say, VLAN 10, HR in VLAN 20, servers in VLAN 30, voice in VLAN 40, like that. So with the help of VLAN, what we are doing? With the help of VLAN, we are dividing a large local area network into a smaller local area network. This is known as segmentation. This is known as segmentation. Segmentation means dividing large network into a smaller network. And guys, if you are connecting all distribution layer switches together, then segmentation is going to be very complicated. managing, configuring, troubleshooting will be very complicated, because for each VLAN you will have one subnet, and on all the access layer switches, distribution layer switches, you are going to create the VLANs. You are going to put some ports in VLAN 10, 20, 30, 40. So we need more flexible management. We need more flexible management. So what we can do here, we can use now core layer, right? We can use core layer. At each building we can place one router. This is just an overview, because in 2 hours, guys, it's not possible to cover everything in detail, right? So at each building I can use one router. Right? At each building we have one router. Now if you have one router at each building, see the benefit. First benefit, guys, earlier your distribution layer switch was responsible for routing between the VLANs. Like here, if I have 4 VLAN, so which device will perform routing between the VLAN? This distribution layer switch. Now you can hand over the routing task to your router. Your router can be responsible for internal routing. Second, if you are connecting all distribution layer switches together, right? So between the building, which device is performing routing? Your distribution layer switches only. So load can be high on distribution layer switches if the network size is large, or if you have many VLAN, multiple VLAN. Creating multiple VLANs, managing, routing, everything is not possible over here on distribution layer switch. So that's why I have placed one router edge at each building, right? Now at least router is responsible for routing between the building, or your distribution layer switches is responsible for internal routing, like between the VLANs. For inter VLAN routing we have distribution layer switch, and for routing between the buildings we have routers. Third benefit, with the help of distribution layer switch, you cannot connect your network to internet. Distribution layer switch is layer 3 switch. It perform routing, but it not support WAN technology. Right? So if you have the router support WAN technology. Here I can configure NAT. Here I can configure VPN, which is not possible on distribution layer switches. Even on the router you will have port to connect fiber cable, but on distribution layer switches you can only connect Ethernet cable. You can connect fiber cable, but you have to change your module of device. According to the compatibility you have to purchase the module, then you have to use SFP. After that you can connect cable. On router directly I can insert the SFP and I can connect it through fiber cable. Here I can use Ethernet cable. This is my Ethernet cable, because at each building we have one router. So definitely distance between distribution layer switches and router is below 100 meter. So we can connect it through Ethernet cable. Now how to connect these routers together? Now we need to use fiber cable. Here I can use fiber cable. There are 2 types of fiber cable, single mode and multi mode, right? So let's say here I have one fiber cable between building 1 and building 2, one fiber cable between building 2 and building 3. Now all the building can communicate with each other. Segmentation, we can perform segmentation at distribution layer, at the core layer. At both layer we can perform the segmentation, because router has per port broadcast domain, right? So this is in different broadcast domain, this is in different broadcast domain, this is in different broadcast domain. Here we will have the different subnet. Here we will have different subnet. Here we will have different subnet. Or I can use the HSRP protocol. This is what, guys, this is actually your CAN, campus area network. This is nothing but the CAN. we can say CAN 1, right? And like this you can have multiple CAN, multiple campus area network. Let's say this is in India and I have one CAN, one campus area network in US.
Praful sir, some
Yeah,
students are waiting in lobby.
done. CAN 1, CAN 2, India and US. Now we can connect these two campus area network together with the help of service provider. Here now we are not allowed to use our own cable between India and US. India, US. We are not allowed to use our own cable here. Even government will not allow you. Many service providers are there who have already the cable between India and US. You can purchase connectivity from them. They will connect their router to your router in India as well as in US. This is what? This is WAN, wide area network. WAN. So guys, we talked about access layer switches, we talked about distribution layer switches, we talked about the routers, LAN, WAN and CAN. Our main focus is CAN, campus area network. So hope now it is clear to you. We are going to use Ethernet cable to connect N devices. N devices means your PCs, your servers, your printer, your IoT devices, your mobile phones, to access layer switches to distribution layer switch to core layer, and core layer can be connected with multiple core layer as well as with service provider network. So let's suppose here I want to design a network for a company, right? There is one company, guys, let's say XYZ company need one campus area network, and you are the network engineer. Definitely you are not alone, you are one team member. Campus area network. So see, to implement campus area network, you should have knowledge about the networking devices. You should have knowledge about the cables, what cable we are going to use. You should have knowledge about the basic configuration of devices as well as about the protocols. So guys, let's suppose in this company, XYZ company name is XYZ company, need a network, right? Need a network. There are, let's say, 3 buildings, right? 3 buildings are there. Inside each building there are 4 departments. 4 departments at each building. So you know how to separate each department. How to separate each department, guys? With the help of VLAN. That is each types of traffic, right? This is the requirement. You need to design a campus area network where 3 buildings are there. If you know how to design and implement network in 1 building, you can do it in 3 buildings also, and you can connect all buildings together. You can connect all buildings to the WAN also, to service provider network. So what we are going to do here, we are going to design, implement network in 1 building where we have 4 departments, right? In each department, or you can say we have 4 floors. In each department 200 users are there. 200 users are there in each department. Let's say there are 4 floors at each floor 200 computers are there. So first of all, you should have knowledge about the subnetting, right? So how we are going to find the subnet for each department? Let's say your main subnet is your main subnet is 192.168.192.168.0.0/16 main subnet. For department 1, you are going to use any subnet. Let's say I'm saying department 1, my subnet is 192.168.1.0/24. For department 2, my subnet is 192.168.2.0/24. So see, in each department we have 254 IP addresses, right? So my network is scalable. If we need to add some extra employees, we can add. Free spaces are available in each department. 3.0/24 for third subnet, and department 4 with subnet 192.168.4.0/24. These are my subnets for each department, right? Now at each department, guys, at each floor, you need N devices, employees devices, then access layer switch. We can have multiple access layer switch at each department, right? Like let's say one switch, you have one switch with 24 ports, so you can find how many switches are required to connect 200 devices, right? So let's say this is my first floor access layer switch, and here I have the machine and machine. I can connect it through Ethernet cable. Then this switch number 2 is at second floor, where also I can connect N devices through Ethernet cable, department 2. Then this is at third floor. At third floor also I have access layer switch and lots of AND machines. At fourth floor also I have one access layer switch with lots of AND devices. I'm going to connect two PCs here. I have connected only one PC with switch, but what I told you, there are 200 PCs at each floor, like this. Now each floor's employees are able to communicate with each other. Guys, if you have configured the IP addresses, then each devices can communicate with each other, but two floor cannot communicate with each other. See, for the IP addresses as well, first requirement is these client machines need IP addresses, and as I told you, these client machines belongs to finance department, HR department, so those guys are not technical guys. Those guys don't know how to configure IP address on computer. So you have to configure IP here. You can set up the DHCP. You can use a separate DHCP server, or you can enable DHCP service on any networking device, on distribution layer switch or on your router, right? So to connect all distribution layer switches together, access layer switches together, I'm going to use distribution layer switch. This is my distribution layer switch 1. Here I can connect this distribution layer switch and access layer switch like this.
And in this scenario, our distribution layer switch is also a L2 switch, right?
No,
Not the
distribution
L3
layer switch is L3 switch. Access layer switch is
switch. Okay.
L2 switch.
Okay.
Guys, the difference between L2 switch and L3 switches, see, these are the access layer switches are L2 switch and distribution layer switches are L3 switch. The difference is layer 2 switch means the switch which forward traffic on the basis of layer 2 information. Layer 2 information is MAC address. That device is called layer 2 device. Any device which forward traffic on the basis of layer 2 address, MAC address, is known as layer 2 device. And any device which forward traffic on the basis of layer 3 information, which is IP address, is known as layer 3 switch. So distribution layer are layer 3 switches and access layer are layer 2 switches which forward traffic on the basis of layer 2 information. And distribution layer switches are layer 3 switch. It can perform traffic forwarding on the basis of layer 2 address also and on the basis of layer 3 address also, right? So now you can see I have three distribution layer switches. Why I have 3 distribution layer switches, guys? For the load balancing, for the traffic distribution, for the redundancy, we can have more than 3 distribution layer switch as well in the real time, right? Then even for the better stability, better connectivity between distribution layer switches, we can connect distribution layer switches as well together, right? Now first try to understand the protocol configurations here. Add some more port. Yeah, now I can connect this switches like this. Let's say 2 cable are there between the distribution layer switches. We can have more than 2 link also. If you need more bandwidth between distribution layer switches, you can connect multiple cable, 5 cable, 8 cable, 16 cable, right? Now this is, guys, LAN, local area network. Now here I have core layer, router 1 and router 2, right? Again, why I have 2 router? For the load balancing, for the redundancy, for primary and secondary scenario, I can connect like this. See, you can assume, you can say this is a campus area network or this is a local area network. Like we can assume this is nothing but one floor. One floor. Or I can say this is one building. Building 1, building 2, building 3, building 4. Then this is a campus area network. If this is floor 1, floor 2, floor 3, floor 4, then local area network. And these all devices can communicate with each other. But guys, let's suppose there is one server room. Here I have one server room where I have lots of server. So can these employees access this server? No. Let's say this server room is connected with internet. So can these employees access this server? No. Can these employees access internet? No. So what we can do? We can connect my core layer to internet now. ISP1, ISP2. And now you tell me, if I have configured the scenario correctly, then can my end devices access server room or not? Where I have lots of servers and server room is already connected with internet. Answer is yes. Reason, all the internet is directly connected with each other. Yes or no? ISP's network are already connected together. So now these employees can access this server room. Today our concern is to not understand how these employees are going to access this server. Our requirement is, agenda is to understand how these all employees are going to communicate with each other, how we are going to segment the traffic, how we are going to create 4 departments here, then how these employees will access internet, right? So we'll live this network, and after that you will see at the end all machines and devices will be able to access the internet. On the internet, let's say there are some servers. There are some servers. .8. Here also same servers are reachable from both the ISP. You can load balance the traffic between ISP1 and ISP2. You can configure ISP1 as primary ISP, ISP2 as secondary ISP. Totally depends on the configuration now. How the topology will behave, how user will access internet, how user will communicate with each other. Those all things depends on configuration, right? Let's say I have one server as well. Here, let me use one server. This is, let's say, centralized server. This server should be accessible from all the employees. Just 1 minute, guys. Now, try to understand the required configuration. Here. So configuration. Before that, I am going to turn on these devices as well. See guys, first requirement is all end machines should have the IP address, right? So as we have 200 PCs at each floor, it is very complicated to configure IP address manually. So what we can do, we can configure DHCP here. So the first thing is DHCP. First of all, we need to configure DHCP here. DHCP, right? After that, guys, we have 4 types of traffic, and we are going to segment the traffic. How we are going to divide each department with the help of VLAN. So second required configuration is VLAN. We have to configure VLAN here on distribution layer switches as well, and on access layer switches as well. VLAN. After the VLAN, with the help of VLAN, we can divide the network virtually. Then inter VLAN routing. How 2 different VLANs are going to communicate with each other. Inter VLAN routing, right? Guys, for the inter VLAN routing, what we need default gateway. So we have to configure default gateway as well. Default gateway. Now I have multiple default gateway, multiple distribution layer switches are there, 1 2 3, right? But default gateway can be only one. So here we are going to configure redundancy, FHRP protocol. FHRP means we have 3 physical gateway, and by combining these 3 physical gateway, I am going to create one single logical gateway with the help of FHRP protocol. I can configure any. There are 3 types of FHRP protocol: HSRP, VRRP, and GLBP. Right? HSRP and GLBP is Cisco proprietary. VRRP is an open standard. So let's configure VRRP here, right? So the next configuration is VRRP. RP. After that, routing. Inter VLAN routing means communication between two different VLAN. Right? Now guys, how to perform routing between access layer switches to, like you can say, end devices to these routers. To access internet, first these devices have to communicate with router. That is called internal routing, right? So here I am going to configure any routing protocol, let's say OSPF. So next configuration is OSPF. Then these end devices can ping to router, can communicate with router, but cannot access internet, because these machines are using private IP address, and on the internet we are using public IP address. So by default, private and public cannot communicate with each other, and the technology which we are using to make it possible is known as NAT, translation, right? So here I have to configure NAT. Then I have multiple ISP, right? So maybe I want to configure primary and secondary. This ISP should be my primary ISP. This should be the backup ISP. So how to track the ISP? I have to configure SLA. So these are the guys basic required configuration over here in this scenario. Then only these employees machine can communicate with each other, can access the centralized server, and can access internet. This switch is not getting a start. What happened here? Yeah, now fine. So let's begin. Without wasting time, let's begin the configuration. First of all guys, what I told you, see, some more configurations are required here, right? For the real time perspective, your requirement can be sometime, let's say PC1 and PC2 should not communicate with each other. These PCs should not communicate with each other. So here I can configure switch port protected. I can configure switch port protected. Let me write here some more configuration here. Switch port.
Extremely sorry. What is the meaning of SLA here?
IPSLA. SLA stands for what? Service level agreement. So whenever you are going to purchase connectivity from ISP will sign one agreement that my connectivity is going to be up for 24/7, right? So how you are going to track the ISP, that ISP is available always or not, with the help of SLA.
Okay.
Switch port protected, guys. Then in real time we are monitoring the traffic also. Like let's say this employee, this is RAM. I want to check which type of traffic RAM is sending to this server, or which type of traffic this RAM is sending to the internet. So how I can monitor it? We can monitor it with the help of SPAN, switch port analyzer. So we can configure SPAN also here. SPAN. Then guys, see, between distribution layer and access layer switches, switch 1 is connected with this switch, and this switch is also connected here. So there can be loop, right? Loop can form here between access layer switch 1, distribution layer switch 1, and distribution layer switch 2. So to avoid the loop, here we have to configure one protocol, that is STP protocol. STP, right? There are many features under STP that we need to enable. Whatever features we are enabling in real time, I will enable here as well. Then between the distribution layer switches, I have multiple link, right? So spanning to, by default STP is already running by the way on switches, right? We need to only change the mode of STP. And guys, whenever you have redundancy, topology is in loop, a spanning tree protocol is going to block one link, right? So between distribution layer switch 1 and switch 2, STP will only allow one link, either 0/0 or 0/1, right? So if you want to utilize both link, you have to configure ether channel here, right? So we can configure ether channel also. These are the basic configuration, ether channel, and many more configurations are there. But these are the required configuration. These are the guys required configuration that you have to configure, then only end machines can access internet. After that, after configuring these all protocol, you have to secure all networking devices. You have to configure password on the console port, on the line VTY port, so that no one can access the devices, right? Only authorized people should be allowed to access this device, should allowed to delete the VLAN, to create the VLAN, right? So we can configure enable password, line console password, line VTY password. For the remote access, let's say there is admin PC. So this admin PC should be able to access all devices remotely from the centralized location. So we need to configure telnet and SSH also, right? So we are not talking about those protocols now. Let's focus on the required configuration, right? And guys, as I told you, VLAN is required. So see, you have to configure VLAN on all the switches, but there is one protocol called VTP. With the help of VTP, I can create VLAN on any one switch, and VTP protocol will propagate that to all switch, right? Then we need to configure access port and trunk port. See, there are two types of switch port. What do you mean by switch port? First, switch port means port of switch. Port of switch. Switch port means the port which forward traffic on the basis of layer 2 information. Always keep in mind, any port which forward traffic on the basis of layer 2 information is known as switch port. And there are two types of switch port. First one is access port, and second one is trunk port. Access port is the port which carry traffic of single VLAN, and trunk port is the port which carry traffic of multiple VLAN, all VLAN, right? So this PC is belongs to HR department, right? So definitely I will put this interface in, let's say VLAN 10. Means this port can only carry traffic of VLAN 10. But guys, link between distribution layer switch and access layer switch, this link is going to carry traffic of this PC also and this PC also. This PC belongs to, let's say, admin department. So this link is going to carry traffic of HR department as well as admin department. So this port should be trunk port, because this link is going to carry traffic of multiple VLAN. So we need to configure access and trunk port also. Again, to configure the trunk link, we have one protocol, that is DTP. I can use that protocol to form trunking here. These all links should be configured as trunk. All link should be configured as trunk. So guys, if I will talk about the sequence of configuration. So first of all, we are going to configure switch port. Switch port. Here I am writing in notepad. First of all, we are going to configure switch port, means port of switch, layer 2 port, switch port, right? The port which is connected to end device will be access port. And link between switches will be trunk. and we'll use the DTP protocol. We'll use DTP protocol for the trunking. So now let's begin the configuration. Let me access layer switch 1 first. Guys, this is my subnet for each department, right? Now for department 1, I'm going to assign VLAN number 10. For department 1, I'm going to assign VLAN
Hello, sir.
10.
Hello, sir.
Yeah.
Yes, sir. Sorry, sir. I am asking a questions. Sir, what is management VLAN and how to use in this network?
Management VLAN, as I told you, you need to access these devices remotely for the management, right? So there is one admin PC. This PC should have access, telnet access of all these devices. So on all these devices, we need one IP address to access it remotely, right? That for that IP addresses, we'll use one separate VLAN that is called management VLAN. So whatever VLAN you are using for the management will be management VLAN. It can be VLAN 10, it can be VLAN 1, it can be VLAN 100, anything. Management VLAN means the VLAN which we are using for the management purpose, right? The guys VLAN which we are using for, let's say, data traffic. So what we can say, this is data VLAN. The VLAN which I am using for the voice, I can say what, voice VLAN. The VLAN which I am using for the HR department, I can say what, HR VLAN. So management VLAN is nothing but the name of VLAN. That's it. Then VLAN 40, right?
Hello, sir.
Yeah.
What is a SRT, sir?
What is STP? This is STP.
Oh, spanning tree protocol, sir.
Yes, spanning tree protocol. Right. Now guys, I'm going to put all the ports of this switch 1 in VLAN 10. In VLAN 10. Or let's say this port is in VLAN 10 and this port is in VLAN 20. Like this also I can configure. VLAN 20. So I have some user in VLAN 10, I have some user in VLAN 20, some user in VLAN 30, some user in VLAN 40. On all the switches, some users are in VLAN 10, some in VLAN 20, some in VLAN 30, and some on VLAN 40. Means on all switches we need all VLANs, right? Let's say this PC is in VLAN 20, this PC is in VLAN 30. This PC is in VLAN 40, like this. 40. Server is in, let's say, VLAN 10, or you can have one separate VLAN for the server, VLAN 50, 100, like that. This is 40, and this one is, let's say, again VLAN 10. Done. So let's begin the configuration, guys. Here I am going to access my access layer switch 1 first. And by default, all ports of switch belongs to VLAN 1. Config tree, host name, I'm going to say access layer switch 1. Access layer switch 1. Then interface E0/0. See, if you want to verify the VLAN, do so VLAN brief. So by default, there is only one VLAN, and there are some reserved VLAN. So don't worry about these. These are the reserved VLAN for the different technologies like token ring, those things. We have only VLAN 1. We cannot delete these VLAN. We cannot modify these VLAN. These are the reserved VLAN on switches, right? By the way, by default, we have only one VLAN on switch, that is VLAN 1, and all ports are member of that VLAN, right? You can see all these ports are member of this VLAN, VLAN 1. Now I am going to create some VLAN here. So guys, what I told you, to create VLAN, we can use a protocol called VTP, VLAN trunking protocol. There are some requirement of VTP. What is the requirement? Requirement is link between switches must be configured as trunk. Then domain name must be same. If password is configured, then password must be same. So I am not going to create VLAN now. First I am going to ready my topology for VTP, right? means I'm going to configure link between switches as trunk, right? And guys, for configure trunk, what we can do, we can use DTP protocol. So here I'm going to use DTP only. Interface range E0/223 and E1/0. These are the port you can see on switch number 1 connected with distribution layer switches. So on these port, I want to configure trunk. I want to configure these port as trunk. So what I can do, I can say switch port trunk encapsulation.1q. Encapsulation protocol, trunk encapsulation protocol is .1q. We have two protocol for encapsulation. This is just for VLAN encapsulation. Whenever switch will forward traffic from the trunk link, it will encapsulate the VLAN ID. How? With the help of this protocol. This protocol will add the VLAN tag. Another protocol is ISL, but nowadays we are not using ISL, we are only using .1q. After that I am saying switch port mode trunk. Right, now you can verify the trunk. So interface trunk, done. You can see these all ports are configured as trunk. Encapsulation protocol is .1q and native VLAN is VLAN 1, means it will not perform tagging for VLAN 1. Even we can change the native VLAN. Now guys, I have configured it on access layer switch 1. If you will check distribution layer switch 1, here also you will see the trunk is automatically formed. So interface trunk. Now you can see which interface, 0/0, right? 0/0, which is connected with this switch, is configured as trunk. How it is possible? It's possible with the help of negotiation, right? So instead of running trunk command on access layer switch, it will be better to run on distribution layer switch. Automatically all access layer switch is going to form trunking. So on this switch, I'm saying host name D switch 1, distribution layer switch 1, then interface range E0/023. These all 0/023. Switch port trunk encapsulation.1q and switch port mode trunk. Do so history. I will copy the command and I will paste same command on distribution switch 2 also. Right, because here also you can see 0/0, 0/1, 0/2 and 0/3 is not there. Actually this switch is not connected with switch number 4, right? So what we can do, we can connect one more link here. Just a minute. I'm going to use 0/3 here. Okay, done. Now let's connect it. So guys, my running configuration was in RAM, and RAM is volatile memory. So configuration has lost. Again I have to configure. Now you can see again the default host name, right? Config T host name, I'm saying D switch 1 and interface range E0/023, switch port trunk encapsulation.1q and switch port mode trunk, and do so history. Let me copy the command. Right, only thing is here I need to change the host name. Let me use notepad to modify the host name here. Host name on switch number 2 is going to be switch 2. Copy and let me access distribution layer switch 2. Enable config T and paste the command. Done. So interface trunk. Now you can see all these interfaces are trunk. Now I need to paste this command on switch number 3 and host name is going to be D switch 3. Copy and let me paste it over here. Enable config T 0/0/123, correct. Done, guys. So I am done with the trunking configuration. All the links are configured as trunk. You can verify. So interface status. Done. Done. Now on distribution layer switch 1 I am going to create VLAN. How many VLAN I need to create? VLAN 10, 20, 30, 40. Before that, VTP domain name is, let's say, Cisco. I have configured VTP domain name Cisco. So you can see it has changed name from null to Cisco. Now I am going to create VLAN 10. Name, let's say, HR. Then I am saying VLAN 20. Name, let's say, admin. Exit. Then I am saying VLAN 30. Name, let's say, data VLAN. Exit. And name 40. VLAN 40 name, let's say, server. Anything. Exit. Right. So VLAN brief. Now you can see we have these all VLANs, guys, but there are no any ports in this VLAN. Now let's verify the VLAN database of access layer switch 1. On access layer switch 1, so VLAN brief. Guys, you can see automatically I have these all VLAN, right? On any switch you can verify. The VLAN is automatically configured on all the devices. So VLAN brief. So VLAN brief, you can see, right? On any switch you can check the VLAN done. Now next thing is we need to put the devices in VLAN, in the appropriate VLAN. So let's access layer switch 1. Here I have one PC in VLAN 10. Which port? E0/0. Switch port, access VLAN 10. This is the command to put a port in a specific VLAN. Then guys, interface E0/1. Switch port, access VLAN 20. Done. So VLAN brief. Now you can see 0/0 is in VLAN 10 and 0/1 is in VLAN 20. Correct. Now access layer switch 2. Enable config T host name a switch 2 and interface E0/0. Switch port, access VLAN 20. Done. Three. VLAN 30. And 0/3. Switch port, access VLAN 10. Now we are done with the VLAN configuration, trunking configuration, DTP configuration, VTP configuration. Now guys, next thing is how this PC will get IP address. So we are going to configure DHCP. So see, either I can configure DHCP on this server, or I can configure DHCP on Cisco devices. So you tell me where you want to configure the DHCPs, on server or on Cisco switch. Even you can configure it on router.
On server sides, Praful.
Okay. So by the way, server is also Cisco IS device only. So console is going to be same. Let me access it. And I have 4 VLAN, right? So I need 4 DHCP pool. One for VLAN 10, one for VLAN 20, one for VLAN 30, one for VLAN 40. So host name, here I am saying host name, server. Right? Then guys, first of all, interface F0/0, no set and IP address. So this server is in VLAN 10, and for VLAN 10 we have what subnet? 192.168.1.1. So IP address 192.168.1. Let's say 100 I am using here for the server. 255.255.255.0. That's it. Now IP DHCP pool VLAN 10 is the name of pool. Which network I am going to advertise for VLAN 10? 192.168.1.0, right? Then subnet mask 255.255.255.0. What will be the default gateway IP address for the users in VLAN 10? So guys, the default gateway IP address is going to be virtual, right? Virtual. So let's say dot 1.254 I will configure on this switch, 253 I will configure on this switch, and 252 I will configure on this switch. And let's say dot 200 is the virtual IP address, right? For all the VLAN, like 1.200 for VLAN 10, 2.200 for VLAN 20, 3.200 for VLAN 30, and 4.200 for VLAN 40. This will be my virtual gateway, right? So I will configure VRRP. In VRRP I will define that default gateway. So let me say here router default router 192.168.1.200, which is the virtual IP address. Now it is not reachable, correct guys? Then I need one pool for VLAN 20, pool VLAN 20, where I am going to define network 192.168.2.0/24 255.255.255.0, and default router 192.168.2.
Sir, excuse me. Sorry for the interruption.
Go ahead.
Sir, you have missed to IP DHCP pool VLAN 10. You didn't mention it, just VLAN only mentioned in configuration.
Yeah, that is name of the VLAN, bro. Name can be anything. I can say HR also.
No, VLAN 10 we need to mention, right? VLAN 20 is this
Where I need to mention
subnet.
VLAN 10? In DHCP we don't need to mention any VLAN.
DHCP pool VLAN 20 you have mentioned, right? It's before
This
VLAN
is name,
10.
bro. This is name. It can be anything.
Oh, yeah, I know, but VLAN 10 is not mentioned. Just you mention in VLAN only. That's why.
So no problem.
Okay.
That is
But
name. Name can be anything.
Okay.
No problem.
Okay, sure.
3.0 is the network. Here network is going to be 3.0, and after that IP DHCP pool VLAN 40, network 192.168.4.0 255.255.255.0, and router 192.168.4.200, right? So guys, I have created pool for all the VLAN. Do so run section DHCP. So you can see this is the pool for VLAN 10, this is the pool for VLAN 20, this is the pool for VLAN 30, this is the pool for VLAN 40. I have only defined the network ID and the default gateway IP address. You can configure DNS server IP also, TFTP server IP also, right? And I need to exclude one IP address from VLAN 10, which I have already configured on this server. So I can say IP DHCP exclude address 192.168.1.100. So it will not offer this IP address to the client machine. Now guys, tell me, if this PC want to assign IP from the DHCP server, IP DHCP, will this PC get IP address? Yes. You can see this PC have what IP? 192.168.1.1, right? PC5. And what is the default gateway of PC1? 192.168.1.200. That is also fine. The default gateway IP address is also correct. PC2, IP DHCP. Why PC2 is not able to get IP?
Yes, sir. PC2 in different VLAN, VLAN
Yeah,
20
so
and
we have
server.
the pool for VLAN 20 also, no? So VLAN brief.
But server and PC in different VLAN.
So guys, 0/1, 0/0 should be in VLAN 10 and 0/1 should be in VLAN 20. So here is the wrong configuration. Interface is 0/0, switch port access VLAN 10, and interface is 0/1, switch port access VLAN 20. Now so VLAN brief. 0/0 again. What happened? 0/1. 0/1 is not showing. VLAN 20 is there.
You are in PC2,
So
not PC1.
interface is 0/1 switch port. Access VLAN 20.
Sir, you are open switch 2, not switch 1.
Okay, great. Do so VLAN brief. I am on wrong switch. So interface is 0/0. This is correct. This should be in VLAN 20 only. Okay, let me take you to switch 1. Access there, switch 1. Here it is. Yeah. Enable. And so VLAN brief. So 0/1 is in VLAN 20, correct? So MAC address table is this switch learning MAC address of PC in VLAN 20. Yes, this PC should get IP address from the DHCP server then. Now here we have to troubleshoot, guys, right? What is the issue here? So what we can check here, we can check the spanning tree. So a spanning tree, which switch is the root bridge switch?
Server should be connected with trunk port. I think it's connected with VLAN 10 port with access port.
Which port?
Server where we configure the DHCP.
Yes, this server is in VLAN, guys, 10. So only VLAN 10 user can get IP address from this server, right? Only VLAN 10 user can get IP address from this server. So for VLAN 20, 30, 40, what we need? For VLAN 20, 30, 40, server belongs to different subnet. So default gateway should be there and default gateway should be reachable. But I don't have any default gateway for VLAN 20, 30, 40, right? So now let's configure the VRRP first. Let's configure the VRRP. After that, VLAN 20, 30, 40 will get IP address from the DHCP server. So let me access distribution layer switch 1. On distribution layer switch 1, so VLAN brief. So we have the VLAN, right? Let me create the SVI here. Interface VLAN 10 IP address. On switch number 1, I will use last IP address from the subnet. Switch number 2, second last IP address. And on switch 3, third last IP address. So 192.168.1.254 is the last IP address. 0. Right? For VLAN 20, IP address is going to be 2.254. For VLAN 30, 3.254, and for VLAN 40, 4.254. 4.254. Do so IP route. So there is no any route available in the routing table. Do so IP interface brief. So guys, these ports are administratively down. See, on real devices, virtual ports will be up, but in the virtual, these ports are down. So let me run no set command. Interface range VLAN 10, VLAN 20, VLAN 30, and VLAN 40. Say no set. Done. Do so history. Here is my configuration. Do so IP interface brief now. Now you can see these ports are up, and even you can check now routing table. Do so IP route. It have installed all the prefixes in routing table. Now for distribution layer switch 2, VLAN 10 IP address will be 253, and I am going to add one more command here, that is no shutdown. No shutdown command for all the VLAN. Here also, for VLAN 30 also, for VLAN 40 also. And we need to change the IP 253, 253, 53, second last IP. Let me copy. Rest everything is going to be same on distribution layer switch 2. So access the switch and paste the command. Enable config T, and let me paste these commands. Done. So IP interface brief, you can see. Done. And so IP route. Done. Now on switch number 3. On switch number 3, IP address is going to be 252. 2 2 2 and 2. Copy and paste on distribution layer switch 3. Enable config T. Done. Now I have created the SVI on all the switches. Now I can configure VRRP, right? So let's suppose, guys, I want to achieve load balancing here, right? Like for VLAN 10, switch 1 should be the active switch for VLAN 10. Switch 2, standby, standby. For VLAN 20, switch 1 should be standby and switch 2 should be active, and switch 3 should be standby. For VLAN 30, standby, standby, active. And for VLAN 40, let's say again switch 1 is active, standby, standby, like this, right? Or you can configure switch 1 as active for all the VLAN 10, 20, 30, 40. Totally depends on scenario. You want to achieve load balancing or you only want to configure redundancy. So let me access distribution layer switch 1, and here say interface VLAN 10. How to enable VRRP? VRRP and then group number. Group number for VLAN 10 I am using 10. You can use any group number. After that, IP address. So tell me guys, virtual IP address for VLAN 10, which I have defined as a default gateway, 192.168.1.200. This is my IP address. Done. Right? For VLAN 20, interface VLAN 20, group number 20, IP address 2.200. 2.200. For VLAN 30, for load balancing, you can change the priority. We'll do that later. Let's make the topology configuration easy first. Done. So I have configured the VRRP. Do so. History. Let me copy the command. I'm going to paste the command on switch number 2 also. On switch number 2, see, configuration is going to be exactly same. So by default, all switches have same priority. It will perform election on the basis of IP address. On switch number 3 also. Done. Now let me take you to switch 1. Sorry, distribution layer switch 1. And here you can check so standby. So standby. So VRP and brief. Master. This switch is the master switch for all the group. Master for VLAN 30 also master. For VLAN 40 also this switch is the master. And you can see for VLAN 10, state master virtual IP address is this one, virtual MAC address is this one. Priority is by default 100. Master router IP address this one. And downtime, leave it these things. Fine. Everything is okay. Now switch 1, distribution layer switch 1 is the active switch for all the VLANs. If this switch will goes down, then switch 2 will become active switch. Switch 2 will become active switch, because guys, preemption is by default enable. Even you can disable it, and you can track as well, like the router, your core layer router. Those are the advanced configuration. This is the basic configuration. Now we have the DHCP server in different VLAN, so I have to configure helper address here. I have to configure helper address. So go to interface VLAN 20 and say IP helper address. What will be the helper address? 192.168.1.100 IP address of DHCP server. Now make sure DHCP server is reachable from distribution layer switch 1. So let me ping 192.168.1.100. Guys, will ping work? Yes, ping is working. That means DHCP server is reachable. Now VLAN 20 users should get IP address from DHCP server. So let me again access the PC and say IP DHCP. Ping 192.168.1.200. Yeah, ping is working. Why this machine is not getting IP? VLAN 20. So run interface VLAN 20. IP helper address is correct. Now this machine should get IP. Maybe it is taking some time because of spanning tree protocol. 30 seconds. Even we can change the spanning tree protocol. We can configure RSTP for faster convergence. But still there is some issue. Let me try on PC2. Say IP DHCP. What is the issue now? 192.168.1.100. Yeah, it is reachable. Why other VLANs are not able to get IP address from DHCP server? Access layer switch 4.
Server should connect with switch trunk port, I think, because it's connected with switch access port, that is VLAN 10. So that's why it's assigning IPs to VLAN 10 PCs only.
So MAC address table, MAC address of VLAN 20 PC5. So IP all. So MAC address table address. Yeah, it is learning MAC address as well. On which port? On 0/1 port. 0/1 port is connected with distribution layer switch 1. Correct. I can do one thing. Let me enable the debugging on DHCP server just to check that DHCP server is offering IP address or not. Debug IP DHCP server and events. And now let me try to assign IP again on PC5. IP DHCP. Yeah, DHCP server is offering the IP address. When DHCP server will offer the IP address, it will receive it on this interface, which is okay. Just wait a minute. Switch 4. Config T interface E0/3 no switch port and IP address 192.168.1.99.255.255.255.0. So I have configured this port as layer 3 port. Now this port is not member of VLAN 10. And what I have to do on server, I have to define the default gateway IP address. Configure T, say no IP routing here, disable routing, and IP default gateway 192.168.1.99 is the default gateway IP address. Ping 192.168.1.99. I'm able to ping fine from distribution layer switch 1. Let me check reachability to DHCP server. Distribution layer switch 1 ping 192.168.1.100. So IP route on VLAN 10 interface, it will forward traffic to VLAN 10, which is going to receive it for VLAN 10. It will forward it to switch. Just a minute guys, there is some issue. I have to check the packet flow. So what is happening? See, when I am pinging to this IP address, the default gateway IP address of server, not the default gateway IP address is changed. Got the issue? What was the issue? On the server guys, default gateway IP address was not configured. So on switch number 4, first of all, let me again make this port as layer 2 port. Interface is 0/3. No, sorry, switch port, and do so IP interface brief. Done. And switch port access VLAN 10. And server should have what default gateway IP address? Virtual gateway IP address. So on the server, say IP default gateway 192.168.1.200. Now ping 192.168.1.200. This ping should work now. Ping is working. Distribution layer switch 1 can also ping the server now. Distribution layer switch 1, here it is. Ping this IP address. Ping is working. And now let me check PCs. Now this PC should get IP address, IP DHCP. Yeah, now you can see. So guys, what was the issue? Issue was server was not able to forward the traffic to distribution layer switch 1 earlier. The reason, default gateway was not there. So whenever VLAN 20 user will try to get IP address, it will generate what? Discover message, which is the broadcast. It will forward to distribution layer switch 1. On distribution layer switch 1, you have configured the helper address of DHCP server. It will convert the broadcast discover message to unicast and then forward to server. When server will receive the traffic, source will be what? Source will be the VLAN 20 interface IP address on distribution layer switch, like 192.168.2.254, and route was not available here, like default gateway was not configured here, right? So whenever a device need to send traffic to different subnet, default gateway is required. So now I have configured the default gateway. Now PCs are able to get IP address, different PCs in different VLAN, right? Now PC2 can also get IP DHCP, but VLAN 30 users cannot get IP address. Why? Because I have not configured helper for VLAN 30. So you can see this machine have IP 2.3. All machines are getting correct IP address, right? But VLAN 30 users means PC3 IP DHCP. No, this machine cannot get IP. PC4 can also not get IP DHCP. No. So what we can do now? We can configure helper address for these VLANs as well. Let me take you to distribution layer switch 1 here and say interface VLAN 30 and IP helper address 192.168.1.100. Interface VLAN 40 IP helper address 192.168.1.100. Now all machines can get IP address. Let me again take you to PC3 and say IP DHCP. Done. And VLAN 40 users IP DHCP. All machines are able to get IP from the DHCP server. Now from PC number 1 I'm going to ping PC5 VLAN 20 user ping 192.168 dot. First of all, let me ping my default gateway. See, I am able to ping my default gateway. Let me ping default gateway of VLAN 20 2.200. I am able to ping. Now let's ping user in VLAN 20 2.1. I am able to ping, right? Even I can ping VLAN 30 user 3.1. I can ping VLAN 40 user 4.1. Right? So now you can see my all departments are able to communicate with each other. But guys, these users are not able to access internet. Right? So now let's configure the distribution layer and core layer. Right? Till now, we have configured this network only. Again, in this network, many more configurations are required. Let me do one thing. Let me change the spanning tree protocol for the faster convergence. Right, on distribution layer switch 1, I can say spanning tree mode and rapid PVST. You can run this command on all the switch to change the spanning tree mode. Now see, PC1 and PC5, these two PCs are able to communicate with each other. PC1, say ping 2.1, 2.1. Sorry. What happened? PC2, let's say ping 192.168.1.1. This PC has goes down. Turn off and turn it on again. IP DHCP. Got the IP. Let me ping PC5 ping 192.168.2.1. See, ping is working. If you want to stop communication between PC1 and PC5, you can configure these two ports as protected port. And always keep in mind, two protected port cannot communicate with each other. A protected port can communicate with unprotected port, means with this port, this port, this port, but two protected port cannot communicate with each other. So as these are PCs of different VLAN, we can stop the communication. Simply here I can say interface range is 0/0 and 1, 0/0 to 1, and switch port protected. Right? Now if you will check the connectivity, again from PC1 I'm going to ping same IP address, and this time ping is still working. Switch port protected, clear MAC address table dynamic. So run interface is 0/0. This port is protected, and 0/1. This port is also protected. Okay, why ping is working? Because both belongs to different VLANs. So communication is actually happening via distribution layer switch, not directly. But if both PCs belong to same VLAN, then you can configure the protected. Let me do one thing. Let me put both PC in same VLAN. Here I'm going to put E0/1 in VLAN 10. Switch port access VLAN 10. Now PC5 will get IP address from VLAN 10 subnet. So PC5, and let me say IP DHCP. Why this machine is now not able to get IP? So VLAN brief, these are the troubleshooting only. Both port are in VLAN 10, right? So IP all. So this machine have 2.1 incorrect IP address. IP 192.168.1.5/24 and 192.168.1.200. Ping 192.168.1.200. Able to ping the gateway IP address, and let me ping PC1 1.1, not able to ping because of protected. PC5 is able to ping default gateway but not able to ping PC1. So this is one security feature here. Then you can configure the port security here. You can configure the SPAN here, right? So guys, it is not possible to configure like those features now because we have very less time. Let me configure distribution layer and core layer link, right? So what I'm going to do here, I'm going to make this port and this port as layer 3 port. Then I will configure one IP address, let's say subnet between router 1 and this switch is 10.1.1.0/24. Here subnet is 10.1.2.0/24. So distribution layer switch 1 interface E0/ or E1/0, say no switch port, and IP address 10.1.1.1 255.255.255.0, right? After that, router 1 R1, say no here. And guys, see, after configuring IP address on router and distribution layer switch, we need to exchange routes as well, right? Like in the routing table of this distribution layer switch, there are some route VLAN 10, 20, 30, 40. We need to advertise those route to router, this router, right? Then only router can send reply from ISP2 and devices. So what we can do, we can configure any routing protocol. So let's configure OSPF routing protocol here, right? Before that, I'm going to configure IP first on router. Enable config T interface F0/0, I think, yes, no set, and IP address 10.1.1.2 255.255.255.0 no set, and do ping 10.1.1.1. If ping is working, now I can configure the routing protocol. Do so IP route. See, on the router we don't have any subnet of VLAN 10, 20, 30, 40, right? So let's configure the routing protocol here. Router OSPF process 1, and we can do one thing. We can directly enable OSPF on interface F0/0 IP OSPF 1 area 0, right? Then on distribution layer switch 1, say interface E1/2 and IP OSPF IP routing router OSPF 1 network 10.1.1.0 wildcard mask 0.0.255 and area 0, right? Soon OSPF neighborship will come up. Even we can change the network type here. So IP OSPF neighbor. So neighbor is in two-way state, so it will come in full state. Interface E1/2 IP OSPF yeah, now you can see, I think on this switch IP OSPF command on interface is not supported. So IP OSPF neighbor. Now we have neighbor. So whatever prefixes you will advertise in OSPF here, it will advertise to router number 1. So let's advertise all LAN prefixes. Router OSPF 1 and network 192.168.1.2 0.0.0.255.255. This network command will advertise all prefixes in area 0. So IP OSPF interface brief, you can see. So IP OSPF interface brief. OSPF is enabled on all VLAN interfaces as well as on this physical interface. So now if you will check the routing table of router 1 routing table, so IP route, so you can see we are learning these all prefixes here. Router is learning these all prefixes, means LAN user can ping router. Now router go to PC1 here, and from PC1 let me ping 10.1.1.1. so see, ping is working, right? I'm able to ping router 1, but LAN user are not able to ping internet. 8.8.8 is not reachable. Ping 8.8.8. even default gateway will deny the traffic. Default gateway is going to deny the traffic because route is not available for 8.8.8. so what we are doing for the internet, we are configuring default route, right? On edge router on R1 you will configure default route towards ISP1. now you can redistribute that default route in OSPF. automatically all distribution layer switches will get default route, right? Before that you should configure OSPF here also, OSPF neighborship here also, right? OSPF neighborship. Then we should integrate the internet. So guys, to integrate the internet, first of all let me configure the internet router. In 10 minutes I am going to cover the configuration. This was just a demo session. After that Arun will tell you about the course, about the training. So on ISP router let me create one loopback. IP address 8.8.8.8 255.255.255.255. then interface F0/0 is my WAN link, say no set, and on the WAN link I am going to run subnet 1.1.2.255.255.0. what subnet I am running between ISP1 and router 1? 1.1.1.0/24. by the way, here we should use /30 because this is the public IP address, payable, not free, right? so better to say 252 here. Done. Now again let me take you to R1 router 1, and guys let me configure IP on WAN port first, F1/0 no set, and IP address 1.1.1.1 255.255.255.252. now can I ping to internet router? Do ping 1.1.1.2. see, I'm able to ping internet router. Can I ping 8.8.8? no. Reason, route is not available for 8.8.8, and it is not possible to configure route because like 8.8.8 there are million of server on internet, so we cannot configure route for the internet. Here we will configure the default route, IP route 0.0.0 0.0.0 and exit interface F1/0, and next hop IP address is 1.1.1.2. now can I ping 8.8.8? yes, you can ping 8.8.8. you can see ping is working, correct? Can I ping 8.8.8 from my LAN interface? Again no. see, ping 8.8.8 and source fast ethernet 0/0. ping will not work. Why ping will not work? Because when I am pinging 8.8.8 from this interface, in that time source IP is 1.1.1.1, right? ISP have route for this IP address, but when I am pinging 8.8.8 from this interface, that time source is 10.1.1.1, right? ISP don't have route for this IP address, so ISP is going to drop it. ISP is not going to even accept the private packet with private IP address. So now here we need to configure what? NAT, network address translation, right? So to configure NAT, I can create one access list number 10, say permit, which submit 192.168.0.0, 255.255. With the help of access control list, I have specified my subnet, like for which subnet, for which network I want to perform translation. Then define inside and outside interface, which interface is outside, which interface is inside. So F0/0 is outside, so say IPNAT outside, and interface F0/0 is inside, so say IPNAT inside. After that, IPNAT inside source list, match source from list number 10, access list number 10, which I have created. So source is going to be this subnet, right? If source will match, then it will translate into the IP address which is running on interface fast Ethernet 1/0, right, which is the public IP address. And to enable PAT, I'm saying overload. That's it. Now guys, my PC can access internet. PC1, let me take you again to PC1. IP, DHCP, got the IP, and ping 8.8.8.8. See, I'm not able to ping destination host unreachable. Whenever you are getting this error, destination host unreachable, that means your default gateway don't have route. If default gateway have route, and if there is some issue, let's say on router number 1 NAT is not configured, right, or ISP is not generating reply, then you will get request timeout error. Request timeout error, right? But this time I'm getting destination unreachable error. That means default gateway don't have route, right? Even you can check distribution layer switch 1 routing table. So IP route, there is no any route available for 8.8.8, as well as there is no any default route. So I have two options. Either I can configure default route here manually, or I can redistribute the default route in OSPF on router number 1. Or I can say IP route 0.0.0, 0.0.0, E1/2, and next hop IP 10.1.1.2. Must specify a L3 port 1/2. IP is 1.1, I think. Do so IP interface brief 10.1. Do so IP route IP route 0.0.0, 0.0.0, 10.1.1.2. Done. So IP route. Now default route is there. So now let me try to ping internet from ISP, from PC1. From PC1 again, let me ping 8.8.8, and now you can see guys, I'm getting the reply packet, right? So now end machines are able to access internet. Any PC, not only PC1, any PC. Let me take you to PC3, let's say, which is a part of VLAN 30. Ping 8.8.8.8, right? Ping is working. In the same way, we will integrate internet to ISP2. After that, we can configure the SLA. Then we can track the ISP with the help of SLA, and we'll integrate that in NAT, right? So this was just a basic overview of campus area network. Guys, in the CCNA syllabus, you are going to learn these all things in very detail, right? After the CCNA syllabus also will cover each and every topic of CCNA. You will be able to design, configure, and troubleshoot a small network, medium sized network, and large network, right? Now this is one branch. Even one branch is not fully configured. We need to live ISP2 also, router 2 also. We need to form OSPF neighborship here also. Port security, many configurations are required in LAN side, in WAN side. And after that, if you have multiple sites like this, then you are going to configure the VPN there. And guys, in CCNA, you are also going to learn how this server can be accessible from the internet, how 8.8.8 can access this server, right? Again, we have two options for that. Either I can configure a static NAT here. Static NAT means bidirectional NAT. Bidirectional NAT means You can access internet and internet can also access you. Now I have configured PAT. PAT is unidirectional translation. You can access the internet, but internet cannot access you, right? Or you can configure the BGP protocol here between ISP and router 1, right? With the help of BGP, we can advertise our own subnet to the global internet. And these everything you are going to learn in the CCNA course. Okay, so now Arun, are you here? So Arun is not there, so you guys can talk to Arun in the group if anyone is interested for the course. That's all for today. We have seen how to design a small network for a company, right? These are the basic and mandatory configuration to access internet. Now you can see all end devices are able to communicate with each other, as well as all end devices are able to access internet. If anyone have any question, please ask. Otherwise, I will leave the session because I have another session, for the SD-WAN. Yes, guys.